All right, everybody, welcome back here for applications of quadratics. Um, Today we're going to do that. We're just going to go back over some word problems. We've seen some sprinkled throughout the assignments in class. We're going to go highlight a couple more specific questions and get you used to applying quadratics in all of our equation solving strategies to match whatever situation we are presented with. Um, Quadratic functions help forecast business profit and loss. So we want to figure out what's the maximum profit we can make, or how can I minimize the cost in my business. Some other examples are plotting the trajectory of moving objects, so something flying through the air, or maybe the shape of a pond or a skateboard ramp, um, or just assist in determining what is the min or maximum value of the given situation. Um, the primary types find the value of one variable when the other equals a specified value. So if you know the x value, okay, substitute x in to get the corresponding y. Okay, an example of that would be how high is the rocket after 5 seconds? You plug a 5 in for your time, okay, to get the appropriate height. Other ones are just plain when's the rocket hit the ground? That would be an x-intercept question, okay? Others are just how high did it reach? Okay, or how low did it go, according to the given situation, which then you're just finding the vertex. Okay, so speaking of vertex, okay, here's our vertex formula. We've seen this in our 4.2 notes and 4.3 notes. So you're just applying opposite of b over 2a as your x value, plugging that back in to find the corresponding y, thus resulting in your vertex. Okay, so let's get right at it here. Okay, here's a situation where we are throwing a baseball in the air, okay, and its height h at any time t is modeled by that equation. Okay, so when is the ball at its maximum height? All right, so here's our situation. Okay, we throw a ball up in the air. When, according to time, is the ball at its maximum height? So we are finding the x-coordinate of our vertex. So we're just simply doing the opposite of b over 2a. So negative 80 over negative 32 gives us 2.5. So after 2.5 seconds, we'll just assume it's seconds. Okay, so it took 2.5 seconds for the ball to be at its highest point. Okay, now what is the maximum height? Now is when we substitute this t value in our time into our original equation to find the height. So we're doing h of 2.5. All right, so you guys can type this in. You can type it in with me if you want. I'm going to be back and forth with the calculator here a little bit. Um, Negative 16 times 2.5 squared plus 80 times 2.5 plus 8, and the ball is 108, and we'll say feet off the ground. That's pretty darn high, but I don't know what units of measurement are given in the question. Okay, so there we're just simply finding the vertex. Okay, one part of it is one part of the vertex, the time, the other one is the height. Okay, the second examples here are finding the height after a given time. So how high is it after 4 seconds? So since seconds, time, is modeled by t, okay, all we're doing is plugging a 4 in for t. Okay, so we're doing h of 4. All right, and you can type that in. You should get 72. And then the last question is, when does the baseball hit the ground? Okay, so we are looking for how high it is when it hits the ground. Well, how high is it when it hits the ground? It's 0 feet, inches, whatever unit of measurement. It's at 0. It's on the ground. Okay, which means y is 0. You need to solve for x. That's the definition of x-intercepts. Okay, so we set our height equal to 0, and then we solve for x. In this case, we're solving for t. All right, you could try and factor that. I see a greatest common factor of 8 in there. However, if we pull an 8 out, it's still not factorable. So I'm just going to go straight for the quadratic formula. Okay, A is negative 16, B is 80, and C is 8. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so I'm going to type my discriminant in my calculator here, pull it up. So I'm typing in 80 squared minus 4 times a times c, 6,912. So x equals negative 80 plus or minus the square root of 6,912 all over negative 32. The square root of 6,912 is not perfect. However, I don't want the answer, if someone said, how long did it take you to get somewhere? You don't say, oh, 5 plus the square root of 38 over 2 minutes or seconds. You would just have to round it according to, minutes and seconds. So I'm just going to type this in my calculator. So I'm going to do the plus 1 here and the subtraction here. So negative 80 plus the square root of our answer. Hit enter to do our numerator calculation. And then divide by negative 32. I get negative 0.098 seconds. And then the subtraction piece, negative 80 minus the square root of 6,912. Hit enter and divide by negative 32. 5.098 seconds. Okay, so when answering this question, you can't say, oh, it hit the ground after negative 0.098 seconds. That doesn't make sense. We cannot go back in time. If we would explore a little further what's going on here with the baseball, okay, this is you throwing the baseball at time 0. Okay, the ball hits a little after 5 seconds. Okay, so why do you get a negative x-intercept? Well, you release the ball up here already. So actually, you're releasing the ball at 8 feet. That's our y-intercept. So think of someone, 6 foot, a little taller than that, and they throw a ball as far and as high as they can. They're releasing it not at ground level, they're releasing it above their head, okay? Which means the parabola is going to start here and land here. So if we would track that parabola backwards, that's where that negative time comes into play. However, that's not really in our appropriate domain because you can't go back in time. So we're pretty much throwing that one away, and we only want to keep the 5.098 seconds. Okay, so just this one example alone, measuring the trajectory of a baseball, we're able to predict the height after a certain time. We're able to predict when it hits the ground. We're able to know when it's at its highest point and what is the highest point. Okay. So let's get into another example. It's different, the area example. We did one of these with the chicken coop question. I think it was in 4.2. Let's look at this one and see how that compares. So Farmer Joe has 1,000 foot of fencing to construct 6 equal-sized rectangular pens. What are the dimensions of each pen so that he maximizes the area? Okay, that's important, maximizing the area for his animals. All right, so we first have to figure out, how does Farmer Joe want to organize his 6 rectangular pens? Does he want to build 6 of them spread out wherever he wants individually? Okay, if he does, he's not making very good use of his materials. Couldn't he share, the pens could share a fence to separate them? Kind of like this. If we put all 6 of them together this way, at least we're sharing a fence. It's still separating each pen, but we're sharing, the fence in between, which is going to save materials, thus resulting in a larger area for each pen. Some of you are probably saying that's not the best way to do it. The best way to do it is to do a 2x3 to get to your 6. Okay, and you are exactly right, because that's the most shared sides that we can possibly have. All right, so we're going to get rid of these ones down here. because that doesn't make sense. All right, so everywhere where there's a line is a fence, and that fence has to total 1,000 feet. Okay, so I'm going to label mine. I'm going to put my X up here like this, and my Y's down here. So everywhere where there's a horizontal distance, and again, I'm just doing each individual pen because that's what the question's asking for. Each pen, some people choose to do the whole thing is X or the whole thing is Y. I'm choosing to do it this way. Okay. Um, what I'm going to do next is continue to label all my X's and all my Y's. Okay, so I need to use that 1,000. So I have, let's see, 369 X's plus 2, 4, 6, 8 Y's, totaling 1,000 feet. All right, the area of my pen, sorry about that, the area of my pen is going to be length times width. So that is 3x times 2y. So that's 6xy. So how can I maximize? I need a parabola in order to find the maximum. It's got to be a parabola, quadratic equation in order to find a vertex. All right. So how am I going to do that? Well, I'm going to simply solve this equation over here, my materials, my 1,000 foot of fence equation for y equals, and then substitute in for the y in my area. So let's get y by itself over here. So I'm going to substitute this expression here, plug that right in for y here, and that should give me a quadratic equation. So let's take a look. Area equals 6x times negative 9/8x plus 125. Let's distribute, multiply this thing out. So 6 times negative 9/8 is negative 6.75 x squared, and 125 times 6 gives me 750 x. I now have a quadratic equation. Okay, so now that's the equation I need to maximize. So I'm going to do the vertex formula to maximize it. So the opposite of b over 2a, it's negative 750 over 2 times negative 6.75. So really, I'm doing negative 750 divided by 13, negative 13 and a half. Pull my calculator up here so you can see what we're doing. So negative 750 divided by negative 13 and a half gives me 55 and 5/9. Okay, you can make it a fraction if you want. Okay, it'll give you improper, which is fine. I would rather keep it exact at the moment. We don't want to result in an error just because a rounding error. All right, so that's the x value. Each fence is going to be 55 and 5/9 feet wide. Okay, for each of my pens. Now, how do I find the corresponding length? Well, I can go back to my equation up here that resulted in 1,000 feet of fencing, which I have manipulated down here, solve for y, and I can substitute this answer back in there to figure out what the y dimension is going to be. So y equals negative 9/8 times your 500/9 plus 125. So negative 9/8 times 500/9 plus 125. Okay, 62.5 feet is our other dimension. Okay, so to answer the question, what are the dimensions of each pen? That's just x by y up here. So the dimensions are going to be 55 and 5/9 feet by 62.5 feet. Okay. Now, one thing I like to do, and a lot of questions ask a follow-up, what would the maximum area be? Okay, so what you could do is take your 62.5 times your 500/9. All right, that gives you the area of one pen, but we have 6 of them. Okay, so the maximum area, okay, is going to be 20,833 and 1/3 feet squared. We got that by just taking 6 times the area of one pen. All right. What if we took over here, because when we did our vertex formula in this box, okay, I only found the x coordinate of my vertex. What if I plug that 55 and 5/9 back in to the x values for that equation? Okay, what if I plugged it in there? All right, what we could do is then confirm our answer of 20,833 and 1/3 feet squared. So if I plug that in, negative 6.75 times 500/9, kept it exact, plus 750 times 500/9. I should get that same, 750x, what did I do wrong? 6 times 125 is 750, 55, negative 6.75 times 500/9 plus 750 times 500/9. I got a mistake somewhere. It should be confirmed. Let's take a look back at our work just to see. Um, let's type in again here real quick. Apologize here for the mistake. 500/9 squared plus 750 times 500/9. There's our answer. 20,833 and 1/3. I must have typed something in incorrectly. I'm not really sure. So there are 20,833, okay. 20,833 and 1/3 would be the corresponding y value of our vertex, okay, which this here corresponds to this here, which confirms everything. Again, I apologize. I must have overlooked something in typing it in, okay. So that's a nice thing at the end. You love it when a plan comes together, when that output there of our vertex, our maximum area, actually matches what our max area would be given the situation, length times width times 6 pens. Okay, so right there's confirmation that we did something right. Okay, again, I apologize for that little hiccup there. All right, so let's look here at another type of question, maximizing profits. Okay, so any business owner, even maybe student council, this is a perfect example. We don't want to put forth all this money and effort into a situation and not know what we're expected to make or if we are expected to make any money. So here's a situation where um, increasing the cost of a ticket, you know, or having it lessen is going to be more people, and then the more you make it, fewer people buy it. Here's a situation where we can kind of play and juggle what do we want our ticket price to be if we have a desired profit in mind. Okay, so let's read the situation here. NOHS is hosting a homecoming dance and expects that 800 students will attend when the ticket price is set at $10 a student. They notice for every 10-cent increase, the number of tickets sold goes down by 5, which makes sense. The more expensive the ticket, the fewer people are going to buy it. Okay, so what's the maximum profit possible, and at what ticket price does this maximum occur? Okay, so I'm going to say let X equal the number of increases that we have in the ticket price. Okay, so to find how much money we're going to make, okay, our profit is going to be the number of tickets we sell times the price per ticket. All right, so how are we going to put this in terms of X, the number of increases? Okay, so the number of tickets we're selling, okay, is predicted to be 800. However, we're losing 5 people per ticket increase. The price per ticket currently is set at $10. However, it's going to increase 10 cents per increase. Okay. So what we have to do now is turn this into standard form. Okay. Right now it's kind of in factored form. We have to multiply this out to put it in standard form and then find the maximum, the vertex. Okay. We can't find the opposite of b over 2a unless it's in standard form. So we're going to FOIL this thing out. 800 times 10 is 8,000 plus 80x. Negative 5x times 10 is negative 50x. And then negative 0.5x squared. Okay, so there's our profit equation. If we clean it up, I'm going to put it in order. Ax squared, bx, and c. That's what standard form is, descending order of our exponents. So negative 0.5x squared plus 30x plus 8,000. And now I can do the opposite of b over 2a. So negative 30 over 2 times negative 0.5. It's negative 30 over negative 1, which means there's going to be 30 increases in the ticket price. All right, and let's see what 30 increases will do to our profit. So we're going to substitute 30 back in for x to find our maximum profit. So we'll type that in. Negative 0.5 times 30 squared plus 30 times 3, or excuse 30 times 30. I got to redo that. And plus 8,000. So $8,450 is what we are predicted to make. That should be a 30 right there. So our profit is $8,450. So to answer the first bullet, what's the maximum profit possible? Okay, that would be $8,450. Okay, at what price does the ticket occur? Okay, now we're going to go up here. Price per ticket is that factor there. I know I need 30 increases. All right, down here. So I'm going to substitute a 30 in there to get my ticket price. So $10 plus 10 cents times 30 increases. That's 10 plus 3, thus resulting in a ticket price of $13 per ticket. Okay, so that one's a little bit different in terms of setup and application. However, it definitely applies to situations. Any small business, is going to weigh their options like that when it comes to setting prices of any item for that matter. Okay. Let's do one more here. Okay, another area model, and then we'll let the geometry example up for you guys if you want to try one on your own. Okay, a painting measuring 3 foot by 5 foot is surrounded by a rectangular frame of uniform width. The combined area of the frame and the painting is 30 square feet. What's the width of the frame? Okay, so I always like to draw a picture. Okay, so there's our painting, but it has a frame around it. Okay, so this painting is 3 by 5. Oops. Painting is 3. Let's do it. 3 foot by 5 foot. All right. We know the combined area, so the area of the whole thing, the blue box, okay, the dark blue box is 30 square feet. So if I can find the dimensions, the length and width of the dark blue box, I can just set that equal to 30 and then solve for x. Okay. What we don't know is how wide this frame is all the way around. Okay. Now the frame is of uniform width, so it's not going to be, 3 feet on one side and, 2 feet on the other. It's going to be the same all the way around. All right. So if we do this, all right, it's 3 feet as far as the height, but we have x dimension here and x dimension here. So we're adding x dimension twice. So we have 3 plus 2x for our height, and then 5 plus 2x for our length. So we're going to multiply length times width and set that equal to our area of 30. Okay, so we need to FOIL this thing out. So 4x squared plus 16x plus 15 equals 30. And in order to solve this, it's got to be equal to 0. So I'm going to subtract 30 on both sides. So there's our quadratic equation. All right, so if I solve this quadratic equation for x, that'll be the width of my frame. So looking at this, you could go through the factors of, a times c, negative 60x squared, and 16. However, can't do it. Doesn't work. So I'm going to go straight for the quadratic formula. So let me pull out my a, b, and c real quick. A is 4, b is 16, c is negative 15. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So negative 16 plus or minus the square root of 496 if you do the calculation, all over, 2a, this should be a 4 down here, all over 8. Okay. So the square root of 496 is not perfect, so I'm just going to split this, do the addition, do the subtraction, and then we'll adjust the answer. So you can type this in, negative 16 plus the square root of 496, hit enter, divided by 8, you should get 0.784. If you do the subtraction, you get negative 4.784. Okay. So which one of these answers actually makes sense? Well, you can't have a negative width. Okay. If I said in one shop, hey, go cut a frame negative 4.784 feet or inches. Okay. That doesn't make any sense. Once again, that's not in our acceptable domain. All right. Therefore, we have to use the 0.784. Keep in mind, 0.784, our units, is still feet. Okay. So if we took the 0.784 and multiplied it by 12 inches a foot, okay, that frame is about almost 9.5 inches. It's 9.408 inches. Okay, so that is kind of reasonable. It puts it into perspective when we're talking about a 3 foot by 5 foot painting, that the frame would be about 9 inches. Okay, so that would be the width of our frame. Okay, the last example here is another, example. It's a geometry example using shapes, triangle. Um, Go ahead and try it if you choose to do so. We're gonna, well, if you want to, we can go over this in class together. But we're trying to limit the number of items that we're doing, so we're not diving as deep as we normally would into this particular topic. But if you want a challenge, go ahead and try this example here. Give it a go, and then we can talk about it in class. Otherwise, we're going to continue to practice some of the examples that we did throughout this set of notes, whether it's area, whether it's profits, okay, whether it's, you have certain materials and you're building a fence, okay, or just simply measuring the trajectory of an object, how high, how far, what time, when does it hit the ground, etc. So we're using all of our solving methods to do this, and give these a practice, and then we'll apply this knowledge in class when you return.